Hi, welcome back to Section 5 of the Scrape the Planet course. I'm your instructor, Mitchell Edwards. This is pretty much the last video of the first iteration of the whole class. I very well may have added things by the time you've watched this, but in its current form, this is the last super practical video of pretty much the whole thing. Super exciting. We're really just going to be adding a little bit of extra to what we talked about in the last video. In the last video we talked about jobs. And jobs, I basically said, were ways to batch up the work between spiders and scrapers. So if you have a spider, spiders are discovering a bunch of new posts, new users, new comments, and they are creating jobs. And those jobs are going to have a type, so type, and they're going to have, a bunch of other information depending on the type. So that job gets added to a jobs queue, and that is typically, or I would recommend, storing it in the database itself. So this jobs queue is basically its own table in the database, and it's going to contain rows and rows of jobs, and each one is going to have a specific type. So while your spider is adding all of these jobs to the queue, a completely separate program, either a watcher or a scraper, a normal scraper that is just constantly servicing the queue, that is going to be reading stuff out. So let me do some erasing here. So it's going to be reading stuff out of that jobs queue. So you've got this whole list of jobs, and they all have different categories and different types. And your scraper is going to have usually a two-way relationship with the jobs queue. Its primary purpose is to pull jobs off of the queue. So it's going to receive the job, and it's going to look in it and say, okay, this job is of type user. Now, it's going to look and find that it has a template that services a user job. And let's just say that's a function. Usually they're functions or like groups of functions, say. I've seen, or I think I've developed a couple of implementations where it was a full like class and object based system, but essentially you can think of it as a function, and that function is going to actually service all of these jobs. So it's going to take that job, and that job is typically going to have the type user and then a URL, and it's going to read that URL in, and it's going to actually service it. So it's going to, for example, using requests dot get and URL, and it's going to start doing a bunch of stuff with the data on that page. Now let's say it goes to the user's page, and let's draw out the user's page here. So let's just say their name is Viking _sec. So it's going to grab that username, it's going to grab their age, so it's going to pull all of that out, it's going to grab, let's say popularity, not very popular in my case, so it's going to pull all of this stuff out, but maybe it also has a list of posts. Then it's going to add those posts to the queue. That's why I say that it has a bi-directional relationship. It's going to add things to the queue as well as take things off. The primary purpose of the queue servicer, or the scraper that services the queue, is to take things off. Now we're going to add a little bit of extra to this idea. And this extra is actually it's a very simple idea that adds a lot of power potentially if you choose to implement it. And that is prioritize queues. Now, prioritized job queues, I guess I should actually write it out if I can find the eraser. Job queues. Basically, they implement the idea that there are certain jobs that are going to be prioritized above others. So, for an example, I'm going to give you an instance where I've actually used prioritized job queues. Now, one of my bigger projects was I wrote a scraper and a spider to gather data on right-wing extremist sites after the January 6th riots in the US. And one of the things that I noticed that there were certain users that I'll call VIPs. And they're VIPs because they posted especially violent content, they posted especially often, and they were basically posting information that was of particular interest. So maybe information that was directly incriminating that I could archive and potentially give to people for the court cases that would come in the future. So those users would be given a higher priority. And there are algorithmic ways that you can assign priority to a user. One of the ways that I did this was, let's just say, one of the weights, so one of the weighted items that would go into a user's priority is their post count. So post count is very simple. It's just how many times have they posted, how many times have they commented, how active are they on these sites. I might want to prioritize a user based on their post count because they might be particularly entrenched in that community. They might be particularly radical, and that's leading them to post more often in that community. Let's say a simple lexical analysis. So lexical analysis, and I'll explain that here in a second. Basically, this is a very, very simple keyword search. So if, for example, a certain post had the word kill, or violent, or gun, or beat, or anything that kind of insinuated that the user was more violent than the average, then I would assign them a higher priority because they're somebody that I obviously need to watch out for. So the presence of these words would all be thrown, or their posts, rather, would be thrown into an algorithm, a function that would print out or basically give them a score. So lexical score. And it would basically loop over for loop in post if word in violent words. So if it's in this array up here, then we would increment the score. And then it's going to return the score. So that's a very, very simplified example of something that you can do for the lexical analysis. It's basically, the idea of it is to assign priorities based on how interesting this particular page or user or object is to you. And this doesn't just apply, obviously, in my very niche use case. You can use this for stocks. So if a stock has a particular level of volume, so let's say for stocks, our criteria might be volume and price. If a stock is trading at a high volume and its average price is low, then it might be something that you're interested in, or you might want to inverse that. If the volume is low, then the price is high. The whole idea of it is that you are creating algorithms that will assign an arbitrary, usually integer or float-based priority to an object. So these objects might be kind of like mine, where it's particular people of interest, or it might be completely benign. You might just be interested in users on a social media site who are talking about crypto very often. Let's loop through all of their tweets, and for each tweet where they mention a cryptocurrency, then I want to up their priority in the queue. And the way this all kind of draws back to queues is, after you've created these priority assets within a job or within an object, then you're going to create these jobs based on priority and order them based on priority. So your priorities are going to be ordered. So you'll have job Joe 6, priority 10. And then you'll have job Sam 29. Let's make that Sam and not Sans. Priority 9. And then your servicer, your service scraper, is going to go through this queue based on priority. And basically, you're going to get your highest priority people or objects or your highest priority jobs are going to be serviced first. Now, this matters when you're worried that information is going to disappear from the internet. So in my case, I was worried that these people were going to say, oh boy, I just posted something violent online. I need to go ahead and remove that. I was worried that those posts were going to disappear and that I wouldn't be able to archive them first. And lo and behold, those posts started disappearing after people got in trouble for January 6th. They also matter when time is of the essence. So for our stock price scraper, if you're really interested in these stocks that are trading at a high volume and at a low price, then you're going to be very interested in getting those processed as quickly as possible. You don't want to wait on all of these other stocks that you're not all that interested in to, process for you to process the ones that you are interested in. And all of these priorities can be dynamic. So if one particular stock is trading at a high volume one day and has a relatively high price relative to what you're aiming for, then you can assign it programmatically, dynamically, a low priority and assign something else a higher priority. And all of these things are relative. You get to decide how priority is scored and how priority is created. But the whole idea behind it is to have a dynamic, programmatic way to assign priority to the jobs within your queue so that you can process the high priority ones either first or you can throw out to the lower priority ones. So if I've got a user who is on this right-wing extremist site, but all they really post about is memes, or they just post dumb stuff that I'm just not that interested in. They might be a troll, they might be another researcher. I'll assign their profile a lower priority, hopefully programmatically and not manually. And let's say, as we're processing through posts, eventually my service scraper gets across their profile. Well, if their priority is a 2 and I've got a mandatory threshold of 3, basically it's going to throw out every single job whose priority is lower than 3. And that can lead, obviously, you're going to keep those things in the queue just in case their priority changes. But that creates a system where you're not gathering information that you're not all that interested in. Obviously, you can assign all of these priorities manually, but when you're doing this on a social media site with thousands and thousands of people, or on stocks with potentially hundreds of tickers, and all of this stuff has to change dynamically over time, then you really don't want to do that manually, especially if you want that stuff fast and you want to archive it, or you want to trade based off of it. It's very important that you do all of that programmatically and that it remains dynamic. So basically, it's all about creating an algorithm, your own algorithm, that assigns these priorities to your jobs. So it gives a priority to jobs. And then your service scraper, I've already got that written down, is going to order all the jobs. So it's going to service all of the jobs based on their priority. So that is going to go up and down, or down and up. I guess it could go either way depending on how you want to do priority. Priority 1 might be the highest priority. Priority 1 might be the lowest priority. But this algorithm, there's no set in stone way to do it. I kind of gave you an example here with post count, with lexical analysis. Those are 2 ways that I've kind of assigned priority to users and posts and things like that within my previous work. But like I said, it might also be volume. It might be price. It might be kind of like industry volume. So if the locomotive industry, for example, is trading at a massive volume, but Ford isn't really trading at that high of a volume, you might include the industry volume as a weighted asset or a weighted kind of input to your overall algorithm. So all of that is to say, your algorithm has tons of inputs. So the volume, the price, the industry, or like we said up here, the post count, the lexical analysis of that user's post, all of that, but it has an output of a priority score. So all of those kinds of inputs can be weighted. And whenever I say weighted inputs, you can start thinking about machine learning algorithms and all of that fun stuff that can go into that. We're not getting into that. I'm not an expert on that. I haven't studied it enough, but there is an application there for assigning priority to jobs within your queues. In that case, might be a little bit overblown to start using machine learning, maybe like basic regression analysis and things like that within your actual like job queue prioritization, but that's completely outside of the scope of this course. The point is you've got an algorithm that takes in tons of different inputs, or maybe one or two different inputs, and it outputs a priority. And that priority is going to be assigned to the individual job. That's really it. It's, like I said, it's general. I'm not going to explain it with it like an actual example. I gave you an example of what I've used before, but I'm not going to code out an example because I think that it's an important concept to understand. The concept of job queues and the concept of prioritized job queues are very, very important concepts to understand, but not necessarily important ones for you to see me implement within my own code. I might later on write an actual scraper live and do that for fun. But for right now, we're not going to be, actually implementing that, the job queues and prioritized job queues during the course. That's it. Section 5 is functionally done. You're going to have a recap after this to kind of talk about everything that we covered in Section 5. And then we're going to have a really awesome one video call to action in Section 6. That's going to be a blast. I really hope that you do check that out because it kind of wraps everything up that you've learned in this course in a bow and presents the reason why I'm presenting it to you. That is about it. Y'all take it easy. I will see you in the next video.